So let's look at C and D on this one. The following data are available: the mass of the ball, the mean radius of the moon, but not the mass of the moon, which would have been helpful, right? The orbital radius of the moon. This is how far the moon is, right? The mass of the Earth, right? And so what they're trying to say is this: here's the moon, here's the Earth. This is not to scale, right? Here you are dropping this object on the moon, and it's attracted to the moon. But what they're trying to show is that there's also going to be a force of gravity. There'll be one toward the moon, and there'll also be a force of gravity toward the Earth, right? So we can figure out the force of gravity from the Earth, right? The force of gravity is going to be Gmm over r squared, right? And one of these masses is the mass of the ball. The other mass will be the mass of the Earth, right? Okay, because this will be the force of gravity caused by the Earth on the ball, right? And then the radius is going to be, and this is tricky, right? It's going to be the center to center distance, but minus this radius of the moon, right? Because we're just a little bit closer. We're not as far, when we're on the surface of the moon, we're not as far from the center of the Earth as we are when we're at the center of the moon. Did I say that right? Anyway, here, this distance here is 3.84 times 10 to the 8th, right? And then this distance here is 1.74 times 10 to the 6th. So you're going to go this distance minus this. That'll be your radius, okay? So do that, right? This is going to be a very small number, right? It's going to be not significant, right? And then the force that the moon exerts, I was like scratching my head, how would you do that? Well, we already know what it is, right? Because we know the acceleration from this part here, right? So that acceleration is the gravitational constant on the moon. So we're going to use force of gravity as mg, right? Where g is this guy, okay? Whatever you got for that acceleration, you're going to put in there. This is the mass of it, right? Okay, so you're going to get two forces. This force will be exceedingly small. This one will be, I don't know, something like, I can't remember what it is. It's like between 0.2 and 0, or 0.2 and 1 newtons, okay, is this force. So it's significantly larger than this one, okay? And then D says, calculate the speed of an identical ball when it falls 3 meters from rest close to the surface of the Earth, right? So for that one, we're going to SUVOD, right? This will be the acceleration of gravity on Earth, right? So negative 9.81. It's going to fall 3 meters, right? So negative 3 from rest to 0. Solve for the final velocity. Yay! It's only 1 mark, though. Okay. Good luck.